We were at that point in learning about how to draw where we're finding out how to depict circles and circular objects is becoming important. Nothing can make a drawing look less convincing than having circles that don't look right in perspective. This is an important concept. Circles are literally everywhere. You can't look anywhere in an environment without finding them. Cups, trash cans, bottles, plates, clocks, steering wheels, and tires are but a few examples. For right now, I want to look at a more concrete example. So here's an ordinary dinner plate that I photographed on my dining room table. You get the idea, it's round. A circular object, when you're looking at it at 90 degrees to level, is a circle. Here I'm looking straight down on the plate. As I go through these, note that the blue lines on either side of the plate, these are the rule lines in Photoshop. Here I've dropped the camera down just a couple of inches so that the circle is becoming an ellipse. It's not very noticeable yet, but it will be as we go down. Here it is a bit lower, and still a bit lower. It's now looking more like an oval and less like a circle. Technically, this is what we call elliptical. Here I'm at about 50% of the way down. Again, notice that the rule lines on either side, those lines or those sides edges don't look flat, nor do they appear to be becoming anything other than round. Many people when drawing ellipses tend to flatten the edges, and the two keys to remember when drawing ellipses is to draw them narrower at the top and never allow the edges to become sharp or pointed. Also notice that the rule has become flattened, or the circles become flattened into the ellipse, and that the rules lines are consistent. That is, that they always are touching the outer side edges of the plate, no matter how flat that it becomes. The distance from one edge of the plate to the other hasn't changed, while the other one has. Even when we are almost flat, in line with the plate, the outside edges never become pointed or sharp. This is how you can tell if you've drawn a proper ellipse. The ellipse will eventually level off into a simple line, but the extreme edges will never become true points. Before there were computers and everything was in digital drawing, illustrators and designers had to draw everything by hand. We had tools to draw ellipses when we wanted to speed up our drawings or to make them extremely accurate. However, the problem with tools like ellipses, they were limited in size, and they didn't come in every degree imaginable. Ellipses occur from 90 degrees or a full circle all the way to 0 degrees or a flat line. Ellipse guides were in 5-degree increments in intervals from 55 to 15 degrees. But what happened when you wanted to draw an ellipse at 7 degrees? Well, you had to become proficient in sketching and sketching quickly. When we view a circle at an angle, we call that an ellipse. We refer to this viewing angle in terms of degrees. A perfect circle is at 90 degrees. At angles less than 90 degrees, we see various degrees ellipses that decrease until we are at 0 degrees. This is a straight line. Understanding the mechanics of drawing an ellipse is not difficult. Mastering the drawing of an ellipse is. An ellipse has two axes. The major axis, shown here, divides the ellipse across its long dimension into two equal halves. The minor axis, shown here, divides the ellipse into two equal halves across its narrow dimension. The major and minor axis cross one another at 90-degree angles. Here we have a square drawn around an ellipse. After drawing a square in perspective, draw an X across it from corner to corner. This locates the center. When looking at the major and minor axis of the ellipse, notice that the minor axis passes through the center of the square, while the major axis does not. Also notice that the ellipse touches the square exactly in the middle on each side of the square. These are called tangents. Here we have taken a symmetrical shape, an ellipse, and dropped it into perspective. Regardless of how your ellipse is depicted, rolling on the ground or resting on it, the construction should remain the same. Since the minor axis always goes through the center of the square, this is something that can be used to help in drawing it. Knowing that the tangents always touch the edge of the square exactly in the middle can be used to help determine the fullness of the ellipse. Practice drawing ellipses without worrying about locating them in perspective. These all represent a bunch that I've drawn in my rather rusty hand. Draw various sizes and different degree ellipses. After you draw an ellipse, identify its minor axis by drawing a line across its narrow dimension. The line divides each side equally, like this. Start with an ellipse. If I draw a line across it in a fashion trying to determine if this is the minor axis, I can prove that it isn't by folding the drawing over itself. It doesn't fold accurately, and so we know that it is drawn incorrectly. If the minor axis is drawn correctly, where we make the fold, it will create a mirror image when folded. This way, we've done it correctly. When drawing wheels on a car, the first thing to check is whether your minor axis is drawn correctly. The minor axis is always common to the axle of a car. Most of the time, this axle is also perpendicular to the center line of the car. There are some cases, such as where the front wheels are turned in or the wheels have been set with an extreme camber, that they no longer are perpendicular to the center line of your vehicle, but it isn't often that this is the case. Another way to illustrate the minor axis is to relate it to the propeller on an airplane. Here the minor axis of both the propeller and the fuselage are parallel to the center line of the plane. Therefore, they go to the same vanishing point. Remember when creating perspective drawings that all parallel lines go to the same vanishing point. Assuming the minor axis of your ellipse is correct and your ellipse still looks wrong, it can only be one thing, that you've got the degree set wrong. First, draw a box in perspective around the tangent points on your ellipse. Be sure to follow your perspective guidelines. Second, observe where your drawn ellipse contacts the box that you've drawn. If your ellipse does not touch the middle on each side of the box, the degree that that ellipse is drawn at is wrong. So having just watched the little video there on the important rules about ellipses, I'm going to try to put some of those into practice right now. So what I've done here is I've drawn just very quickly a horizon line with a vanishing point, and I'm going to locate a center line down from that so as to kind of keep my box that I'm drawing kind of located or oriented equidistant on either side of that center line. So I'm going to draw the very bottom part of my cube down here and draw some lines back to that vanishing point. Here and here. Make sure I've got equal distance on either side. That'll hopefully make things a little better. Then I need to determine where the back edge of that cube will be, and I'm thinking probably right about here will maintain a good fairly square bottom to that cube. So I'm going to draw lines across from corner to corner to locate where the center of that box is, and it should line up pretty well on that center line, which it does. I'm going to draw some lines up to represent the sides of the cylindrical box that I'm creating here, front and back. So I can locate a couple more lines up here that represents the top surface of that box, into which we're going to place a couple of ellipses. So I'm going to go back to the vanishing point here and back to the vanishing point here. Draw my lines across here and here. That now represents the back edge of the box. So now we have a rather shallow box at the top, and I'm locating the center of that. So now you can see that
as we saw in the video, if an ellipse has to touch at all of the tangents of the perspective box, then this ellipse down here is going to be rather full. Whereas this up here ellipse is going to be much shallower. Now, I'm going to locate my large ellipse guides and clean these up so I can show you what that looks like. So we can see that using the large ellipse guides, this bottom ellipse down here is probably, maybe a 25. It comes pretty close to touching all four sides of the cube, or yeah. The big problem that you have in things like this, as was indicated in the video, is the fact that you don't have ellipse guides narrow enough to draw the top one, because this is a 10, and a 10 is much fuller than is necessary. A 10 would come in, say, maybe right about here. And then a 20 degree would come in somewhere in between that, down and around here. So as you can see, the ellipses get rather full rather quickly, but they get narrow as they go up. I hope that this helps explain things a little bit about how ellipses grow, and the fact that the sides of the ellipses always remain rounded. People make the mistake of drawing an ellipse and always coming down and making it sharp like that, and it's not. It's always a nice rounded edge where it meets the edge of the side. Anyway, all for now. I will see you guys in the next video.